In algebra, the part before the equality sign, I would like to just call section 1, and then after the equality, you have section 2. This thing that connects the two sections is the equality or the inequality. If it's an equal to sign, it's an equality. In an inequality, it would be either a greater than sign, a less than sign, a greater than or equal to sign, a less than or equal to sign, or not equal to. So something not equal to would look something like, let's write it like this, not equal to. Does that make sense? I used to have people challenged by how to remember something is less than or equal or greater than sign. Remember that a greater than sign looks like your right hand when you're writing. So it looks this way, while a less than sign looks like your left hand when you're writing. So that's that, just FYI. Equality is equal to. Inequality is everything but equal to. So greater than, less than, greater than or equal to, less than or equal to, and non-equality. So let's move on. Now the rules of inequality is, the way I like to remember is whenever something goes over an equal to sign, the sign changes. So let's take for example, addition. When you take an addition over an equality sign, it becomes a minus. When you take a minus over an equality sign, it becomes positive. When you take a multiplication over an equality sign, it becomes division. And when you take a division over an equality sign, it becomes multiplication. So let's take some examples. 2x plus 9 is equal to 11. Now, this is a positive 9. When I take it over the equality, it becomes a negative. So 2x is equal to 11 minus 9. 2x is equal to 2. X is equal to. Taking the multiplication over the other side is going to be 2 divided by 2 because multiplication becomes division. So x is equal to 1. Another example, 2x minus 2 is equal to 8. Now, this is a minus. When a minus goes over the equality sign, it becomes positive. So 2x is equal to 8 plus 2. 2x is equal to 10. This is multiplication. When you take it over, the equality becomes division. Sometimes you see people write stuff like divided by 2, divided by 2. That's where that comes from. Over the equality, it changes from a multiplication to a division. So x is equal to 10 over 2, which is 5. Let's do another example. Let's do a division example. So let's say x over 2 is equal to 3. Because you're dividing here, when you're taking this over an equality sign, it becomes multiplication. So x is equal to 6. Sometimes you see people do stuff like, let's multiply both sides by the denominator. So times 2, that x is equal to 6. So as long as you remember these rules, over the equality always changes. Addition becomes subtraction, subtraction becomes addition, multiplication becomes division, and division becomes multiplication. This is all equality. One thing that I want to note about the equality is unique situations when something is multiplied by a negative number. So unique to these two situations, let's say we have negative 2x is equal to 4. Whenever you're taking a negative 2 over, or a negative number over the other side, it doesn't change in an equality. 4 divided by negative 2. So x is negative 2. Another example, negative x over 2 is equal to 3. So moving division to the other side is going to be multiplication. So x is equal to 3 times negative 2. X is equal to negative 6. I want you to remember this situation because that's going to change in inequality. So equalities, remember these laws. Now, inequality, when we talk about inequality, this is a situation where all the rules apply. So these rules apply apart from these unique rules for the negative side. Now, in an inequality, let's say, for example, 2x plus 9 is greater than 11. 2x is is greater than 11 minus 9. 2x is greater than 2. X is greater. So multiplication, send it over, that's division, divided by 2. X is greater than 1. For inequalities, I would always advocate that you put it back into this situation and see whether it makes sense to you. So 2x, which is 1, plus 9 is greater than 11. So if 2 is greater than 1, let's pretend that instead of using 1, let's use 2 instead. So let's change this to 2, right? Because if x is greater than 1, let's pretend like if x is 2, right? So 2 times 2, 4. 4 plus 9 is greater than 11. This is true, right? So you always want to check yourself in inequalities. Now, what's different in inequalities? These negative situations. So let's pretend like negative 2x is greater than 4. In an inequality, whenever the multiplication or the division possesses a negative number, that always flips the sign. So in this situation, we're going to take it over, which means because it's multiplying, it's going to be dividing. So it's going to be x less than 4 divided by negative 2. Whenever you're sending a negative number over, the law still applies. So multiplication becomes division, but the sign flips. So x is less than negative 2, right? Now let's put us back in the scenario or in the equation. Negative 2x greater than 4. If x is less than 2, let's find where x is on the number line. So this is 0. This is negative 1. This is 1. This is 2. This is 3. This is negative 2. This is negative 3. So if x is less than negative 2, it means that it's on a lower number. So let's pick that x is, for example, if x is negative 3, because that's less than negative 2. So if x is negative 3, negative 2 times negative 3 is greater than 4. Let's try that. Negative times negative is positive. 2 times 3 is 6. 6 is greater than 4. So I know this is correct. Now let's do another example with division. Same thing. Let's say negative x over 2 is less than 3. Now, because this is a negative number, let me write this in a different way. So this is like saying negative 1 over 2 times x is less than 3, right? So this is a negative number, so we're going to take it over. It's dividing here. When we send it over, it's going to be multiplying. So x is greater than 3 times negative 2. So x is greater than negative 6. If x is greater than negative 6, let's find negative 6 on the number line. So let's pretend this is 0, this is negative 6, there's negative 5, negative 4, blah, blah, blah. If it's greater, that means it's better. That means we're going in this direction. So let's pick that x is, for example, negative 1. Let's pretend like x is negative 1. If x is negative 1, then let's try it in our equation. Negative x over 2 is less than 3. So if x is negative 1, negative x is negative 1 over 2 is less than 3. So this times this is positive 1 over 2 is less than 3. Oops, the pen is not working, okay. So this is half is less than 3, and this is correct. Does that make sense? So inequalities and equalities are a little bit different in the negative part of things, but otherwise, whenever you're taking something over the equality, the signs always change. Positives become negative, negatives become positives, multiplication becomes division, division becomes multiplication. And in the unique situation where what you're multiplying by is a negative number. In an equality, it remains the same. You just send it over. But in an inequality, that negative number changes the sign from a greater than to a less than, or a less than to a greater than. I hope this makes sense.